In this video, we'll generate the trend line and polynomial of the square root of 1 plus x and its reciprocal. We begin with the data set of the square root of 1 plus x. Our formula, square root of 1 plus x, where the x value is from negative 0.9 to positive 0.9. And its reciprocal, which is equal to our formula, 1 over square root of 1 plus x. And the expansion, the Taylor-Maclaurin series sum expansion, which is the summation of a times x to the power of n, where n starts from 0 to infinity. So we can start from 0 up to infinity, which is 16, good enough. And the value of a, which is equal to our formula, that's negative 1 raised to the power n plus k. So minus 1 raised to the power the quantity n minus k times double factorial. That's double factorial 2n minus 1. So 2 times n minus 1. You completed the numerator. And our value of k will be data validation, list of items, 0 or 1. And save. You correct this. So double factorial of 0 should be 1. So to do that, so if n equals 0, if n equals 0, then 1. Otherwise, calculate. Now it's corrected. We continue with the denominator. So the denominator now, denominator has two parts. So the first part of the denominator, double factorial 2n. So double factorial 2n, 2 times n. That's the first part. Now the second part, the quantity 2n minus 1 raised to the power k. So the quantity 2 times n minus 1 raised to the power k. Then enter. So if k equals 0 and k equals 1, now we can continue with the Taylor-Maclaurin series sum. So R formula, series sum of the x values. So our value of x is this range, comma, and starting from n. So raised to the power n. So n starts from 0, incremented by 1. And the coefficient a, it will be this range. And enter. And we'll chart this. Insert chart. And we use scatter chart. Column is label. And we show the trend line. So series. For the series, we don't have yellow. We change that to green. So that's our series. We show the trend line. Polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. We don't need a title since we are reusing the equation as the label. And here's our polynomial. Then we go back to the series. Point size will be maximum, except for the expansion. The point size should be none, but its line thickness maximum. So here's the trend line and the polynomials of the geometric series and its reciprocal. We calculate these polynomial regression coefficients using Linest. To do that, we complete the Linest matrix starting with the power, which is equal to transpose, because we're using the 8 degree, so 0 to 8. We're using the 8 degree. And the elements of the matrix array formula of the x values raised to the power 0 to 8. Now we can use Linest, starting with the square root of 1 plus x, so Linest dot y and dot x. Then the expansion, Linest dot y and dot x. Then enter. And the reciprocal, Linest dot y and dot x. Now let's compare with the chart. So let's start with k equals 0. So k equals 0, the expansion approximates the reciprocal. So this value should be, so likewise the polynomial regression coefficient approximates the green one. So our coefficient will be 1, 1, 1. So this is 1, 1, 1. And for coefficient of x, it is 0.5 minus 0.494 minus 0.488. Coefficient of x squared minus 0.21 minus 0.124, 0.365, 0.354. Coefficient of x cubed 0.0714 minus 0.446 minus 0.578. Coefficient of x to the fourth 0.0491 negative 0.433, 0.595. Coefficient of x to the fifth minus 0.0183. This is 0.448. That's 0.448. 1.08. Coefficient of x to the sixth. X to the sixth 0.0247. This is minus 0.511. And this is 1.21. Coefficient of x to the 7 0.084 minus 1.28. And this is minus 0.209. Coefficient of x to the 8 minus 0.074, 1.27, and 2.11. Change this to k equals 1. This time, the expansion approximates the geometric series square root of 1 plus x. Likewise, the polynomial regression coefficient also. Starting with x to the 0, 1, 1, 1. Coefficient of x, 0.5, negative 0.488. Coefficient of x squared, negative 0.124, negative 0.125, and it is 0.354. Coefficient of x cubed, 0.04714, 0.0684, and negative 0.578. X to the fourth, 0.0491, negative 0.0455, and 0.595. Coefficient of x to the fifth, minus 0.0183, 3.82 times 10 to the minus 3, and 1.08. Coefficient of x to the 6, 0.0247, 9.96 times That's 9.96 times 10 to the minus 3 and 2.09 or 1.21. And x to the 7. X to the 7, 0.084. This is 0.0656 and this is 2, negative 2.09. Coefficient of x to the 8 minus 0.0764, that is negative 0.0582 and 2.11. This completes the use of double factorial to generate the Taylor-Maclaurin series expansion coefficients of the geometric series 1 plus the square root of 1 plus x and its reciprocal.